Hello, today's objective is that you will perform operations on radical expressions. This is part 2 of the video. In part 1 operation, we focused on adding and subtracting, and in part 2 of the video, we're going to focus on multiplying. So, take a look at the first example. We have 3 root 5 times 8 root 2, and the way we do this is that the coefficients multiply together, and the stuff inside the square roots, which is called the radicands, also multiplies together. So I'm going to do one step and just rearrange all this. Another way to write this would be 3 times 8 times square root of 5 times square root of 2. So I've just put the numbers together and the square roots together. And then these combine and these combine by multiplying. So our final answer here, 3 times 8 is 24. And then root 5 times root 2 is root 10. So that's the answer, 24 square root of 10. Root 10 doesn't break down any farther like we did in objective 0.1, but if it did, we would then break that down. Just like last time, if you feel you do not need to do this middle step because you can just look at it and figure out what the answer is, that is okay. Second example, a little bit different. We've got a number in front of a set of parentheses, so we're going to be distributing 7 times 3 minus root 11, and I will multiply this into both. 7 times 3 is just 21. There's nothing new going on there. Minus 7 times root 11 would just be 7 root 11, because the numbers that are not inside the square root and the numbers that are inside the square root, you put them next to each other with the times, but you can't combine them or simplify them in any way like you can if they're both outside or both inside. So that's it. We can't simplify this at all. And when you look at it, it probably looks like exactly what you would have guessed even before you watch this video. The last example here is a little bit more complicated. This is 2 plus root 7 times 2 minus root 7. And I'm actually going to do this one 2 different ways. The long way and then the shortcut. So the long way would be to FOIL. That would be 2 times 2, 2 times negative root 7 times 2, and root 7 times negative root 7. So, piece by piece. First, 2 times 2 is 4. 2 times negative root 7 is negative 2 root 7. Root 7 times 2 is positive 2 root 7. So you notice just like here, the number goes out front, the root goes last, and they don't combine. And then root 7 times negative root 7, there's different ways you could do this, but I'm going to write this as negative root 49. You notice because both of the 7s are inside of the square root, that means that we can multiply them, unlike the 2 and the 7, because they weren't both in the square root. So you probably noticed some things happen to simplify. Negative 2 root 7 and positive 2 root 7 are like terms, and they are also opposites of each other, so they cancel out. And then square root of 49, you know what that is. That's just 7. So what we have here is 4 minus 7. So our answer here is negative 3. Now the other way to do this is to notice that these two expressions are conjugates of each other. So when you see this, there's a shortcut you can use. If you ever see a plus b times a minus b, these are conjugates. That's the same terms, except one's added and one's subtracted in your binomials. That is equal to the first term squared minus the second term squared. Always. Conjugates, you can use this shortcut. So in this case, the first term is 2, and the second term is square root of 7. So when I set this up, I could write 2 in parentheses squared, and then minus root 7 in parentheses squared. Now 2 squared is 4, minus, well, when you have a square and a square root at the same time, they're inverse operations, so they cancel each other out. So this just becomes 7, and you notice now we're in the same place we were the other way we did it. So 4 minus 7 is negative 3, so we get the same thing. It is not necessary that you know this, because you can always FOIL it and do it the long way, but you notice it is faster. So I do recommend you understand the conjugate method in addition to the FOIL method if you see this. So our objective today was that you perform operations on radical expressions. We focused on multiplying, and that included the conjugate shortcut.